All right. The whole thing last time, we were talking about divide. And if I'm writing divide, which first, obviously divide already exists in Python, obviously. But let's pretend I'm writing divide. And I run into a situation, you give me the two operators. What is it? Like A and B I have here. And I give you back whatever the answer is. You give me two new values, I give you back the answer. You give me two new values, I give you back the answer. Whatever, I'm just doing my thing, I'm acting, I'm doing my thing, I'm dividing. But then, suddenly you call the function where b is 0. And I got a problem. Something exceptional happened, something funny, something out of the ordinary. You gave me a 0. And what do I do about it? I wrote this function in 1991. And you today call divide, but you assigned the parameter b 0. So what do I do? I can't really do anything. Should the program crash? I don't know. Should it ignore it? I don't know. Should it try again? I don't know. I don't know what to do in this situation if you give me a divisor of 0. A dividend, divisor, whatever's on the bottom. Divisor. I don't know what to do. All I can do is take note that something funny happened and communicate to you that something funny happened. And then it's up to you to decide what you want to do about it. So you keep, for example, you keep throwing numbers at me, I keep giving you the quotient. Is that what you get when you divide? Yeah, I keep giving you back the answer. And suddenly you give me one where the divisor is 0. I don't know what you want to do about that. I can't do this, but I don't know what you want to do about it. So all I can do is let you know that something funny happened. Ball's back in your court. Now it's up to you to decide what to do. And this is how I would write the code to raise an exception. If b is 0, I use this keyword here, raise, and then I raise a 0 division error. There's actually a lot of different exception types in Python. They're all called errors. But there's a lot of different exception types already available in there. Conveniently, there's one that exists that's called 0 division error. A lot of times you're just going to have like a general runtime error. But the purpose of this topic isn't to teach you all about how to use and raise and catch and deal with exceptions. It's to let you know that they exist. So this is how a function can raise an exception. If the divisor is 0, we've got a problem. Otherwise, ignore it. Just carry on as if everything's normal. It's fine. But if b is 0, we raise an exception. And raise is similar to a return in that the function stops immediately. The function stops executing. And that exception is actually like being raised by that function. It's being kind of like returned. That function didn't give you back what you expected. It gave you back a special thing, an exception, which is a way to communicate. It's a way to pass a message through the program. Now, catching exceptions. What do you want to do? I call the function that raised an exception. So now we're looking at the exception issue from the other side. First, I was talking, if I'm the programmer writing the code that might have an exception, I raise the exception. I wrote that function. Now I'm on the other side. Now I'm in 2023, and I'm using some code that was written in the past that might raise an exception. If that code I call raises an exception, what do I want to do about it? I don't know. It depends on what I'm doing. Can I ignore it? Can I try again? Can I crash immediately? I don't know. It's up to me. It just depends on what I'm going to do. So, here is a generalized view of what you would say. If I'm using code that I know might raise an exception, and that exception might be important, is I use this special keyword called try. I'm going to try something. If nothing funny happened, all of that code in the try just executes normally, nothing funny happens. But if an exception is raised, it gets caught by that line that says except some error, some arbitrary error. Here, this would be like a zero division error. And then in there, indented, kind of like, think of this as like an if block. Like if the exception was raised, that's how we're gonna handle the situation. And then kind of like an if, after the last block, regardless of what happens, that stuff outside will run regardless. So let's make this a little bit more concrete by showing some specific examples. Example 1. There exists a special value for floating point numbers in Python called NaN. It means not a number. It's a way to have like, okay, this thing is a float. It has a type float, but it has a special value called nan, not a number. It would be like what you could do if you tried to divide by 0, where it's like, it's not defined. It's still like a float, but you can't really do anything with it. It's a special value, not a number. A lot of programming languages have exactly this. In Python, not a number. A reasonable way to manage a zero division error is to use not a number. So the code that we saw, that divide code, raised a zero division error. And that was a way to say, I don't know what you want to do about it, but you got to deal with it. If I'm using that function, I'm going to try to call divide. So not a number example, two numbers, A, B. I'm going to try to call divide, and if divide ran and just gave me back some quotient and everything's good, I go from line 3, I skip lines 4 and 5, and I just return the quotient. If, however, B was 0, meaning that divide raised that exception, then the program won't crash. The program will say, okay, I'm going to handle that exception. If I ever see a zero division error, I'm just going to assign quotient the value, not a number. And then I'm going to return not a number. So this function here, this not a number example, is a wrapper function. It wraps around that other function to just manage the situation of, well, what do you want to do if something funny happened, if you got that zero division error? For this particular example, I just tell the program, okay, don't crash, because the default behavior is like, well, the program crashes, right? How many times have you seen something error, program crash? A lot of times, right? Type error, crashed. Cast or conversion exception. There's a lot of errors that you get that crash your program. Here, it wouldn't crash. It would just say, okay, instead of crashing, just assign the quotient, not a number. Cool. That's all it is. If divide is called and there's no zero division error, then the division occurs and quotient is returned. On the other hand, if zero division happens, we assign not a number to quotient and then return quotient. Example 2. Maybe we wrote some code that asked the user for some input. And the user entered their input wrong. They entered some invalid input. And maybe instead of having the program crash, what we want to happen is, well, just ask the user again. So here's some code. While true, so I've created an infinite loop here. While true, I say, okay, provide operands for division. Great, I get the two values A and B. Okay? Then I'm going to try to divide. Divide A and B. And if that works, the value gets assigned to quotient. And raise your hand if you know what break means. A few people in here. Break is a special keyword that means exit the loop. So I had an infinite loop, but then basically if I call divide and it worked correctly, I say break, which means exit the loop. I could have coded this differently such that I didn't need an infinite loop and a break. I could have kind of changed it. I just felt this was simple. So break means exit the loop. It was an infinite loop, but there was a break, so you got out. Good. If, on the other hand, we try to call divide, and the exception is thrown, we skip all the rest of the code in the try block, and we go down here. And I say, cannot divide by 0, try again. And we go back up to the loop. I'm going to show you like exactly how this would go by running it. So we've got our divide. So here, first, here, I'm calling divide, whatever, fine, and then I try to call it with 0, and it crashes, right? 0 division error. Wait, that's illegal. There we go. Can't do it. Right? It crashes. But I'm going to add this one here, the not a number example. Here I'm calling not a number. I call it with 1 and 1, it should give me back 1.0. If I call it with 0 being the divisor, we get nan. It didn't crash, it just says nan. Cool? Now we'll go to that last example, the keep trying. Oops. All right, provide operands for division, 1 and 1, it's happy. I try to run it again, 1 and 0, it's unhappy. 2 and 0, it's unhappy. 3 and 0, it's unhappy. 3 and 2, it's happy. All right, so the first example was let it go, the program will crash. The next example was, oh, just assign not a number. And now this one was, keep trying until you're good. But see how it's the programmer using the divide, the programmer using the function that might raise an exception. It's up to them to decide how they want to deal with the exceptional situation. Example 3. Maybe it's critically important that your code stops running. So when your program crashes because of an exception, it like crashed. But there's another way to make your program stop that's not crashing because of the exception, like the exception didn't break it, but you can say, okay, we got this exception, now immediately end your program, which is a little cleaner, let's say. So when I say stop running immediately, 1 and 1, I call it great. 1 and 2, I call it great. 1 and 0, it crashes. What? Why would it even? Oh, I see why it's mad. Fine. This is irrelevant. There. 1 and 0. Now the reason we see 0 here is not because the result was 0. Well, I guess, yeah, here, 0 division error. A, B, B, quotient, why? Did you see all these like pop-ups down here? Your session crashed for an unknown reason. Well, I know why, because I said exit, and exit means stop running. This actually just killed Python from executing. We need to restart the runtime. Yep. And that's just a way to cancel your program. Or like I was showing before, another way is to just let the exception just crash your program. Because when you have a function that raises an exception, it's expecting to get handled by that except zero division error. And if the function that called it doesn't deal with it, the function that called it doesn't, if it doesn't deal with it, it just propagates it to the calling function. And if that calling function doesn't deal with it, it just propagates it to the calling function. But eventually you're going to run out of functions. And then the program is then going to throw the exception at you because, well, you were the calling program. You told it to run. Right? So if you don't handle it and you just let it crash, it crashes. Or maybe finally, if you get it, if you get that exception, maybe you just want to ignore it. Maybe it really doesn't matter. So you just ignore it. You catch it and then you immediately pass. Anyone know what the pass keyword does? It's basically, it just tells Python to shut up. If I ever have, let me show you, def if I try to run this, it's going to say unexpected indent block, something or other, if it ever actually runs. Come on. Cell is already running. This is weird. What's going on? There. Incomplete input, right? And it's because like, well, Python's like, well, hold on, you need to have something like indented. And you're like, well, I don't want anything. I just want to have this function there, but nothing in it yet. And then you just say, okay, fine, pass. It's a way to say like, okay, yeah, just there's something there, but it means nothing. That's all. So this means, okay, catch that exception and then do nothing with it. Just ignore it. The point, though, is the programmer who wrote divide raised the exception and said, okay, you were using me and I do the time, and then something funny happens and I raise this exception and I give it back to you. You, if you're using that code, the divide, and it's working normally, great. But if you ever get that exception, it's up to you to say what you want to do about that situation. That's the point. Why care? Well, which of the above examples is the right way to deal with the zero division error? Well, it's a stupid question. The answer is it depends. And I can't possibly know what you want to do in 1991. All I can do is raise the exception, give it to you, and then you get to make that decision. And exceptions are great because it allows programmers to pass around information, like literally like through time, right? Like the programmer in 1991 is giving information to you today that you used their function wrong, which is kind of cool. It gives us a way to kind of like deal with the exceptional situations effectively, and it provides, if doing it meticulously and carefully, you know, going back to here, this like general example of try except, is it kind of gives you this like logical separation between, okay, this is what normally happens, and this is what to do in the funny situations. Just as an FYI. So there's a lot of niceness there. Any questions about exceptions? Yeah. Well, you can't do that. So if you pass it, quotient will probably, okay, I see what you mean. I think I understand your question. Let me check. Let me go back and get the divide. It'll probably not be defined, but let's check it. Is that what I called the function before? Shoot. Ignore what it currently says. Yeah, it's saying it's not defined. Because this value never got assigned here because the exception was raised before any calculation was done or anything. I could say ASD equals 9999, and you run it. It'll say 9999 just because, well, this never got updated. Is that what you were asking? Yeah. Other questions? Now, the point of me showing you this right now is not, like, I'm not gonna, I really don't think I'm gonna have any questions about exceptions on the final, right? But they're an important thing that you've probably been seeing, wondering what the hell they are, and you will be using them eventually. They're very important. Python's a little loosey-goosey with exceptions compared to other languages. Java's very strict with exceptions in a lot of cases. There are some exceptions that you want to catch, and there are some exceptions that you probably don't want to catch. But it's all like situational dependent. For example, like when you have an index error, if you've indexed something wrong, chances are you don't really want to catch those exceptions because that error really is, well, you messed up as a programmer. It wasn't like, oh, a funny thing happened with this code and there was a peculiar case. No, you're trying to index something that doesn't exist. That's a mistake on your part. But all this nuance and nitty-gritty detail of exceptions is something you'll learn more as you go along the way. Other questions about exceptions? No? No, what's next? Oh boy. All right, here we go. All right, now the course is starting. All right, so where do I start? We're at a very big, okay. Remember how I said like the references, that whole references thing, it's gonna piss a bunch of people off? But we're not doing too bad now, right? We're kind of okay with it, you know, we're okay, you know. Well, objects are the next big jump in the course. I don't mean the learning curve is going like this. I just mean now this is a whole new thing we're getting into. For the past few lectures have been a lot of talk about lists, but we've been on lists a lot. Then I talked a little bit about file I/O, which is not something you need to like study, understand, but it's something that you should be aware of. Similar with exceptions. Don't study it. No, just something you to be aware of and learn as you go. Objects, this is a big one. This is like the next big thing we're going to be hitting in this course. And I would say this is like the last big new thing we hit in the course. But if it's not obvious, there's a lot here. Okay, there's a lot of objects coming up. Now, searching and complexity and sorting, don't get me wrong, they're relevant, they're important, they're going to be on like the exam type thing. But it's just a collection of existing ideas that we're using. Objects, whole new idea, all right? And we're going to start simple. Objects are a way to combine data and functionality together in your program. Now, I need to make clear that combining data and functionality is not necessarily something you want to do, actually. It's something we can do. And this is where object-oriented programming comes in, right? And Python lets us do object-oriented programming, where you have a bunch of objects interacting with different objects to solve problems. Lists are objects. Strings are going to be objects. I mean, everything in Python's an object, but the primitive types pretend to not be objects. Once it became able to combine data and functionality, a lot of programmers jumped on the object-oriented programming train and they started combining data and functionality, and they didn't take the time to ask themselves if they should. Just because they could didn't mean they should. And so they did, and now, well. So we're going to talk about objects very carefully. When I learned this stuff, I didn't have the luxury of having as good as a prof as you do. So I'm going to be very careful and try to make clear just because you can doesn't mean you should, so we're going to go about this very cautiously. That said, there will be some examples of me adding functionality to these objects for the sake of adding functionality when really it shouldn't be there, but I'm going to do it just to show you, so you learn. All right? Often people like to keep their data and functionality separate. But objects provides a way to make them the same. But you can actually still keep them separate, kind of, but we'll see. This all comes down to good design of your program. And hopefully, I mean, these are some topics, when I'm talking about good design, with like good code and taking your time to think about how things are implemented, these are things I was talking a lot about near the beginning of the semester, and I've been hitting it throughout the semester. But hopefully by now, it should be obvious to you, based on the amount of experience you have already programming, it should be obvious to you that just because something is functionally correct doesn't mean it's any good. I was looking at some of the assignment 2 submissions, and there are some, like, people wrote some functions that are like, okay, it's correct, but instead of taking a step this way, if I'm here and I told you to get to here, and what I was hoping would be someone took the step to there. But sometimes people will go run up the hall, go outside, high five a stop sign, come back in and end up here, and they're like, see, I did it. And I'm like, ooh, okay, but why? What are you doing? That would be an example of probably not a good way to go about getting to here. Bad example, perhaps, I don't know. But just because it's correct doesn't mean it's correct. Just because it's functionally doing what I asked doesn't mean it's good. This is when it comes down to design, taking the time to think carefully about how we design our algorithms and how we code things. So it's not just about being correct, it's about having good, understandable, and readable code, but also having a nice solution as well, where you're not jumping up and down 100 times before you get to the there instead of just getting there. Maybe at this stage it's not obvious to you, but as you get more and more experience, you're going to see this come up. Big motivation for objects is because it allows us to combine data and functionality, it can help with abstraction and encapsulation. Abstraction is the whole idea of like, I don't need to know how a list object works entirely, like how it works I don't need to know how my internal combustion engine in my car works. All I need to know is that I can turn on my car and go when I need to. I don't need to know how the list works. I know how to use it. I don't need to know how it does what it does, though, in order to use it effectively. That's kind of like abstraction. It allows us to think of things at a higher level and reason about them at a higher level, which can help a lot. If I wanted to say append something to a list, I'm like, great, I could say my list.append. But if I was so focused on what the hell the list was doing under the hood, it gets a lot more complicated to think about appending something to a list. So that's like the idea of abstraction. And encapsulation is the idea of kind of like putting data and functionality that goes together. So it's like encapsulated in a nice place. Lists. Now lists, I will say, I just made a big stink about combining data and functionality and how we don't love to do it. There is a big obvious exception to all of this for programmers, is its data structures. The whole point of a data structure is to store data and probably be able to like manipulate it in some way easily and simply. So data structures, everyone goes like, yeah, okay, we like to keep our data and functionality separate. Unless it's something designed specifically for storing data and manipulating data, then we want that to go together. But more on this over the next semester. But lists. We have data associated with them. the size of the list, the data actually in the list, but there's also some functionality like append, remove, and there's a bunch more associated with it. What do we call this functionality that's associated with an object? What do we call those things again? Methods. They're like functions because they basically are functions, but they're associated with a specific instance of something, and that's the, the implicit argument, yada, yada, yada. You've already been working with objects, lists. Lists are objects. But at this stage, you have not created or defined your own object. That's what we're going to start to do now, is we're going to define our own object. We're going to tell Python, hey, I want to make a circle object. I want to define what a circle is, and then I want to make instances of a circle. So we are going to make circle objects. But in order to go and make a circle object, we need to define a class. New programmers learning object-oriented programming, that's what this is, will often conflate class and object. Even experienced programmers will do it too. The class is the definition. An object is an instance of the class. The class is the blueprint. The object will be like a specific version of what the blueprint instructed us on. Examples will come up. It'll make it a lot clearer, I'm certain. A class is simply the code that defines what it means for something to be an object of some class. For example, we are going to define a circle class, which means all of the information Python needs to make a circle object is going to be within the circle class. Yeah. Going back to lists, there exists a class definition for lists. And whenever you made a list, well, it was based on the definition of what a list is written in the list class. Excuse me. Circle class. So we're going to learn by doing. So what we're going to do is we're going to write a circle class. It's going to be very simple. And then with the class, we're going to make a couple of instances of circle objects, like instances of classes. We're going to make a couple circle objects. An instance of a class is an object. But there's one big question. What is a circle? What is the data and functionality we want our class to have? Now, at this point, we're obviously going about things the wrong way when it comes to programming. Usually, if I want a circle, there's a reason for wanting a circle, and I've got some ideas in mind. Right now, we're making a circle object, a circle class, for the sake of making a circle class, right? So if you're like, this feels contrived, congratulations, you're correct, you figured it out. It is. For our needs, so okay, when I said what functionality and data do we want, well, that's up to us. When we write the class, we are defining what it means to be a circle in our program. So for our needs, we will have a circle know its radius, and that's really the only data we need specifically associated with a circle. A circle really only needs to know its radius, right? And then for the functionality, we're going to have some very basic like geometry calculations, right? Like if I know a circle's radius, I could tell you its circumference, right? I could tell you its diameter. I could tell you its area, right? So the functionality will be calculate this stuff. Now, mind you, the data, the circle has one piece of data associated with it, the radius. Data associated with an object is called an attribute. Depending on the programming language, they might call it a field or something else, but for here, it's an attribute. And then the functionality associated with an object is the method, okay? And although those geometry calculations will return a piece of data, it's the functionality that's calculating the new piece of data, right? Based on the attribute. But again, we'll learn by doing. You'll see the example as we go. So here's how we start writing a class. Just like this. Now, you don't need your doc string at the top. But of course, you need your docstring at the top. What? You start a class by this. Class, and then the name of the class, and then colon. The key word here is class. This is up to me. I could call it, actually no, I can't call it that. I could make a class called that if I wanted, but that would be ridiculous. I want to make a circle class. So a good name to have would be circle. Now, convention time. This is one of those things that if you don't do, Python will happily do it anyways, but other programmers will hate you forever if you do. Classes all start with an uppercase. Everything else started with a lowercase, right? Except constants. You had a variable, start with a lowercase. You have a function name, it's all lowercase, right? Classes, they all start with uppercase. And we use camel case for classes, meaning if I wanted to make a circle is an object class, this is how I write it. You don't use underscores. You start the next word with an uppercase, right? That's camel case. Now here I don't need camel case because the name is just going to be circle, but the convention is uppercase. If you submit an assignment and you don't follow the convention and you say, yeah, but Python ran and it was correct, I'm going to go Python ran, you didn't follow the conventions, you're not really correct. So just because it runs doesn't mean it's right. So follow the conventions, uppercase. Here I've got a docstring that describes what's there. A class for representing a circle based on its radius. The class provides functionality to perform basic geometric calculations, diameter, area, circumference. There. Good enough. Anything I want to be a part of the class is indented under that class keyword. Go figure. The above example contains a start. The class circle starts the class. Anything indented is part of it. Like how anything indented under an if is part of the if. Just like a for loop, a while, whatever. The docstring comment is a simple description of the class. Now, with just this, I can already actually go, I'm going to go down here. Now, I didn't need to go to a new cell. I can just unindent, but it would be kind of ugly to have, to do this all in one cell. So with just this, I can already actually go start making an instance of a circle. There. I've made a circle object. I'll do it again. There, now I've got two. I've made two circle objects. I printed out A, and it doesn't tell me very much. It says, underscore underscore main underscore underscore dot circle object at OX7904C304E5C0, which of course makes a lot of sense. That's like the memory address where it is. And I'm asking, well, what's the type of A? And it's like, oh, it's a circle. It's a circle. Now, obviously, if you're wondering, okay, but what's the point? I can't really do anything. You're right, you can't. You've defined a circle, and we made instances of circles, but there really is nothing in the definition. It's a really useless function or class at this point. But you know, I can check, does A equal B? False. Okay, all right. Is A is B? No, it's false. That makes sense. What if I make A B equal A? A is B. Oh, it's true, right? References. Okay, so everything is like working as it should at this point. There's not much I can do. But this is clearly not very useful. So what we're going to do is make a constructor. The constructor is the code. Now, There's an asterisk associated with this. In fact, do I have a note in here? I do not. Okay. In reality, init is not actually the constructor, but it is for our purposes. Everyone just says it is. There is a funny little nuance there. But the constructor is a very special, super important method that gets called whenever you make an instance of an object. So when I wrote this right here, this goes, creates a circle object in the computer, and runs the code in the constructor, for which currently there is none. There is no constructor defined. And the constructor does all of the setup for us for that object, for that class. So it's the code that says, okay, go create this object, and here's kind of how I want you to do it. Right now, there's nothing there. But we can go and we can add some stuff. This is the constructor. Underscore, underscore, init, underscore, underscore. Warning, everyone listen up. Listen right now. If, in the future, you wrote your init and you try to make an instance and it says something along the lines of, like, no constructor object can't be found, I can't understand, there's missing parameters, arguments, whatever, there's an issue with the constructor and it doesn't take. Make sure you didn't accidentally write this. Okay? It's not int, it's init. I'll show you an example of what I was just talking about shortly. I don't know if we'll get to it today. Now, what this does, let's just work through what I say here. In the above example, we see the special function called init. This is describing how to initialize a circle object. The constructor must be called init. Underscore, underscore, init, underscore, underscore, actually, to be more precise. This is, in Python, they call these magic methods or dunder methods because they're double underscore methods. But it must be called underscore, underscore, init. You never call the underscore, underscore, init, underscore, underscore method directly. You never call it directly, though. The way you call it is by doing this. When I do this, when I say A equals a circle, it calls init. Never try to call init directly. Don't do it. Don't. Never try to call any method that has like underscore, underscore, something, underscore, underscore. Never call those methods directly. If you are, you're doing it wrong. That's how I call this method. Whenever I create an instance, this method gets automatically called. It's also creating an attribute for this instance of the object called radius. And that radius belongs to itself, which is weird. But it totally makes sense, and it will as we go. But at this point, this is a weird idea. Self is a reference variable that refers to itself. And you'll notice that the init function has a parameter in there called self. Self is a super special word, a super special name that is a reference variable to itself. Give me a moment, and I'm going to show you an example of this to hopefully help start making you happy with this idea. You will notice a special variable called self. Self is a reference variable to this, the current instance of the class itself. All methods within the class require that the first parameter is self. This is effectively that implicit argument. You'll see. Additionally, accessing any attributes or methods within the class require the use of self. The self variable can feel a little weird at first, but it's something that will start to make sense as we go. So I'm going to, no, here. With this, print A, we see this, nothing special. But I can actually say A dot radius. Oh, did I not rerun this? There. There we go. Now I can ask A, well, what's your radius? Because A, circles have a radius now, an attribute. It's just a variable, but it's a variable that belongs to the specific instance. And then let's go here. Look at what's happening here. Both circles have a radius. Circle A on line 1 is created, circle B is created line 2, and then I say circle A, your radius attribute is 1. Circle B, your radius attribute is 5. And then when I go back and I ask, hey, circle A, what's your radius? Well, it's 1. Circle B, it's 5. They both have a radius attribute, but the values that are associated with those attributes are different for each instance. Here, we have two objects, two circle objects, two instances of the circle class. We only have one circle class, that's the definition right here. But here, we have two instances of a circle. You could think of attributes, everyone in here is an object, let's say. And you all have an attribute, first name. Raise your hand if you have a first name. There you go. So you all have the attribute, first name. But you all probably have different, there's going to be some people in here without different, but the values associated with those first names, those first name attributes are going to differ depending on who you are. For example, what's your first name? Sure, you, because you. And what's yours? And what's yours? And what's yours? No, you. See, you all have a first name though, but they have a different value. Both circles have a radius, but they have a different value. They are entirely independent from one another. They have the same name, but the value of one has no impact on the value of the other. You can then say, okay, well, all right, it was kind of silly. I'm going to update our circle class. You know, we created the objects. Now if I run this, it's going to be mad. Because it's going to say, no, I need an argument here. Let's get rid of this. I can actually specify upon creation. I went and I added a new parameter to the parameter list for the constructor called radius. But notice, I only gave one argument to the circle constructor. But here it's like, well, this method needs two. Well, the self is kind of ignored. That's the implicit argument. That's the instance that it's called on. Now, this is the constructor, so it's kind of even weirder. But really, you go like, there's two arguments, there's two parameters here. And I go like, yes, but we kind of ignore the first one in terms of giving it the argument, because this will get clear once we see more methods shown. But here, I can specify it exactly. Now here, let me show you an example of what I was talking about with the int. If I accidentally called this int, and I'm doing this, And it's saying, circle takes no arguments. And I'm like, what are you talking about? It takes, there's ones right there. I can see it's got 1 right there, radius, it needs it. And it's saying, circle takes no argument. And I'm, what's going on here? It's because I called it int, not init. And the reason I get so worked up about this is I make this mistake far too often, where I forget and then I yell at my computer and I go like, oh my God, I did it again. Any questions before we wrap up here? I'm going to warn you. Make sure you're paying attention to this circle shit. It's very important. All right, I'll see you later.